So the subject of this presentation is how digital dyeing technology will change the world, is what our mission is as a company, which seems like a very bold claim, dramatic claim to make, but hopefully that will become clear as I go on through the presentation. So what we've done is we've created a completely new way of dyeing textiles to solve the climate damage that dyeing textiles is doing to the planet. So you may have seen these slides before in maybe one of Alan's presentations or something you've attended of ours before, but we keep repeating them because it's such a horrible problem that the fashion industry is causing at the moment. Fashion industry, home textiles, anything that involves dyeing a textile. So fashion now is responsible for about 10% of global carbon emissions, and the dyeing of the fabric that we're wearing counts for 3% of those emissions. It's also the second largest cause of global industrial water pollution. 20% of global industrial water pollution is caused by the effluent, dilated effluent from dyeing textiles. So if nothing changes today, if the textile industry carries on using the same types of machines and the same processes and doesn't change dramatically, then CO2 emissions from dyeing our clothes is predicted to reach 2.5 gigatonnes by 2050, which is a really shocking statistic. I mean, the reasons for that are obvious. You know, the global population is increasing. Fast fashion doesn't look like, even though there's a move to a more circular economy for textiles, it doesn't look like it's going to change that quickly, that soon. These images I've shown at many conferences in the fashion industry, so in front of buyers and designers. And people that have been in the industry for many years will come up afterwards and say, we had no idea the problem that we're causing is this bad, because it's just not seen. So when the fashion industry go in and they do their audits of the factories, they'll maybe see a factory that looks relatively clean, but not see what's pumped out into the waterways, into the river systems. So two images which upset me a lot, you know, and it doesn't matter how many times I show them. This one in the top, in the middle, is Indonesia. And so what's happened here is that the rivers are being dyed, you know, so the wastewater is going into the rivers, then it rains, floods, and we have, here's a mum and dad with I don't know if you can see behind the mum is a little toddler been walking through this sort of dye-polluted water. But in that same country, they have to drill 300 meters into the ground to get to fresh water, which is another really scary statistic. In Turkey now, which has always been a very kind of resource-rich country, they're now drilling in some areas, in the textile regions, 50 meters into the ground to get to water. And this image down in the right-hand corner here, this was the image that really kind of led to the formation of Alchemie's mission. So our founder, Alan, had spent many years in the digital printing industry, I think 10 years at Domino, and then set up Xenia printing, that digitally printed ceramic tiles. And it was being taken to by one of the leading dye manufacturers in China. Took him when he was on a trip to a dye house and took him out the back and showed him this scene of the sort of mud, you know, polluted with dye, that made him decide that this is a problem that needs to be solved. So, you know, you look at these awful images, 30 tons of water is being used to dye 1 ton of textiles. But despite that, water scarcity is a real thing now that is threatening human survival, but also business survival. So one example of that we've experienced is, so just yesterday we were talking to an Italian textile manufacturer with a dye house, who's saying that they're really worried that they can access water to continue running their business. We did a trade show in Turkey recently, and we had conversations with 249 people from 166 companies from 21 countries, and every single one of those textile manufacturers was saying that we're really worried about water scarcity. So we don't experience that here in the UK. We have a very, I'd say, mild climate. So we don't, on a daily basis, see the impact of climate change. But so water scarcity was top of mind. If we can't find a way of solving the water problem and the quantity that we're using, we won't have, our textile industries will die. The other issue of big concern is obviously energy costs. So yesterday we talked to an Italian textile manufacturer who said their energy prices have gone up by 6 times. So, you look at the very low margins in those industries, and it's not really manageable on a long-term basis. The other issue that we're looking to solve is the chemical waste from textile finishing. So what's happening now is that to add properties such as waterproofing, antimicrobial finishes, softenings to fabrics. I mean, this is all the stuff that we wear to go cycling, the gym, our everyday clothes. The textiles, once they're dyed, they go into a huge industrial chemical bath, filled with water, steaming water, lots of chemicals, but that chemical's only needed on the surface of the fabric. It's not needed to penetrate all the way through. And then all of that waste then has to be dealt with. So if I go back also to this image, with some textile applications, there is no need to dye on both sides of the fabric. So what we're saying is that at least half of the chemicals used in textile finishing aren't necessary. And why would you immerse a whole fabric in a chemical bath when the finish is only needed on one side? It could be a settee, upholstery, curtains, that fire retardant, stain proof, doesn't need, to be treated in the way it is today. So we've come up with my slides have gone a bit weird here, but we've come up with 2 solutions. So one of our solutions is a dyeing solution based on digital technology, but it's not the same as, I'll explain in a moment, not the same as digital printing. What we're doing with Endeavour is that we're reducing the water used in the dyeing process by 95%. So we say it's waterless because we don't use any water other than the water that's used to sort of mix the dye up. We don't use any additional water in the dyeing process. And then we use a small amount of water which is used to just clean out the jets between different dye changes, between different colours. So what we're doing is we're eliminating the energy, the hot washing that happens after industrial dyeing. So at the moment, fabric goes through massive tanks of dye and water, 30 tons to dye 1 ton of fabric. And then the excess dye literally has to be washed out multiple times. So sort of maybe 6 washes at 60 degrees, so that when we then buy the clothes and put them in our washing machines, you get very little kind of dye coming out of the fabric. So that's called fastness. So we eliminate the energy reduction, so the CO2 reduction is achieved by eliminating all that post-washing. We have another solution called Navara, and that's for finishing, applying the chemistry to the surface of fabric. So once it's dyed, dried, then we jet just one side of the fabric. And similarly, then what we're doing is we're cutting the chemistry by half. So the principle is we're looking to lay down the exact amount of dye required to penetrate the whole fibre of the fabric. With digital printing, the concept is that the fabric, the pattern is just what is wanted on the surface of the fabric, because if it penetrates, then you lose the resolution. What we are achieving is very flat, even colour. So this is a towel, a cotton towel in the image here. I'm going to start actually passing a few things around. And the towel has only been jetted on one side of the towel, but the dye's penetrated all the way through. So can I just ask some? And I think it was really important to show you some samples, because the challenge, sorry, I'm not going to. The challenge normally with digital dyeing or printing is getting that very even, solid colour without any banding. So what we've developed is a bar with 1,440 nozzles. Each of the nozzles are individually controlled. We're dispensing very much larger drops than you would dispense for digital printing. So whereas digital printing drops are like about 6 picolitres, ours are 10 microns, and we're dispensing around 1.2 billion drops per linear metre, and it's like the difference between firing a very small drop to getting a cannonball, and we're literally kind of firing the cannonball at the fabric so that it can penetrate right the way through the filament of the fibre. And then we use vacuum underneath the fabric to draw the dye down from the bottom as well. So this is a microscopic image of an endeavour dyed fabric, and you can see all of those of you that know about digital printing knows that you can't achieve that result with printing. It's quite a different objective and a different result. So these are some of the things that we've done. We've dyed polyester. Some of them I think are coming around the room. Polyester is very difficult to dye because it's hydrophobic, and it doesn't want to accept the dye. So what we do is we jet both sides of the fabric. So we jet, then we immobilise using IR, and then we flip it round and jet the other side. The cotton samples that I'm passing around, all of these nice bright colours. With cotton, the cotton is hydrophilic, so we only have to jet one side of the fabric, and you'll see that we get this beautiful even colour on the reverse as well. So energy savings with cotton. So for polyester, we will save around 85% of the energy, 95% of the water. Every fabric is, I don't know what's happened to my slides here, I don't know what's happened here. So every fabric is different, which is why we will have lab tests before we do any dye run. So for the cotton versus the current method of dyeing cotton, we are using 95% less water and 70% less energy in the process. For rayon and viscose, we're using 85% less water and 40% less energy. Okie dokie, what's happened here? Right, so our calculations in terms of energy savings has shown us that an existing dye machine in the traditional dye house will deliver a profit of $50,000. But using the technology that we're delivering, given the additional throughput and the reduction in costs, that a dye house can deliver a 1.1 million profit from the machine. So something's gone wrong with my slides here. So there's 4 good reasons why the textile industry needs to change. So we're at a climate tipping point, and the great thing about taking out an old dye machine and putting an endeavour machine in its place in a textile factory is that 85% energy savings immediate, so we're immediately reducing CO2 emissions. It also, if nothing changes, the problem is only going to get much, much worse. And as I said, it's predicted 2.5 gigatonnes of CO2 will be created by the industry if it doesn't move away from the current way of doing things. So as a mission for our company, we want to stop the fashion industry producing 500 million tonnes of CO2. So that's the end of my presentation. Thank you.